viewers and listeners at home. My name is Phoebe Sukaiyayi, the Permanent Secretary, Minister of Education, Kaduna State. Welcome to Kaduna State Radio Television Program e-learning. During this period of coronavirus pandemic in our society today, it is our pleasure to introduce e-learning to our students at home, especially the SS3 students who are about to write their final exams. Therefore, we want to use this medium to ensure that our students are uninterrupted through their learning and teaching through this platform. Our listeners and viewers at home, it is our pleasure to ensure that this period we try as much as possible to bring the lessons that you are used to through our classrooms, through this medium, to ensure that you hold on to your platforms, you hold on to your lessons, to ensure that at the end of it all, you come out victorious. We are using this medium to ensure that we engage you, not only the student, but also their parents and their guidance, to ensure that, yes, Kaduna State is truly the learning center. Welcome to e-learning through the Ministry of Education, Kaduna State. Thank you for listening, and thank you for following up.
Hello, my wonderful viewers and listeners at home. You're welcome to the Ministry of Education e-learning platform. Today in chemistry, we'll be taking you through a topic, electrolysis. My name is Teacher Philip Mamman, and I will be breaking down this concept for you. I plead with you to get your pens and paper ready as we'll be taking this important concept as we proceed. This concept is broken down into subtopics. I'm going to start with the introduction, definition of terms, mechanism of electrolysis, discharge of ions, Faraday's laws of electrolysis, and of course, the application of electrolysis. We all are very used to our bright cell batteries, where we use them to power our torchlights and other devices. You are quite aware that there are chemical substances in these batteries that convert the chemical energy into electric energy. Today, we'll be looking at this concept properly. As you follow me, I will break down this concept to your understanding. I will start by the definition of electrolysis. Electrolysis is a passage of electric current through an electrode with the resultant decomposition of the electrolyte. There are two types of cells. There is the electrolytic cell and the electrochemical cell. The electrolytic cell is a device that converts electric energy into chemical energy. As it's illustrated in the diagram, you can see that it's made up of two electrodes, the red and the black. And of course, the E arrow there shows the flow of electron from the anode to the cathode. The electrolyte is in the basement, and the other cell is electrochemical cell. The electrochemical cell is a device that converts chemical energy into electric energy. You can see it's made up of two vessels containing anode and the cathode respectively. There's a basic difference between the electrochemical cell and the electrolytic cell. One of the differences is the fact that the electrochemical cell is made up of a short bridge or a porous partition that allows the transfer of ions, and the electrochemical cell does not have this short bridge or porous partition. But of course, the electrolytic cell has a positively charged anode and negatively charged cathode, while the electrochemical cell has a negatively charged anode and a positively charged cathode. You also agree with me that on the electrochemical cell, the redox reaction, which is reduction and oxidation, takes place in one vessel. But in the electrochemical cell, this reaction, redox, takes place in separate vessels. Now, there are so many other differences between the electrolytic cell and the electrochemical cell. I'd like to proceed as I will be defining other concepts like the electrode. The electrode is a wire-like, rod-like, or plate-like substance that allows the coming in and going out of electric current. Most often, students use the word passage instead of coming in and going out. The exam bodies are more comfortable with the use of coming in and going out. And that's why I'm emphasizing that when you are defining electrode, you should use the word coming in and going out of electric current. There are three basic types of electrode. As I'm going to be explaining now, we have the anode and the cathode. The inert electrode is a special type of electrode. It is inactive or does not participate during electrolysis. And that's why it is called inert electrode. Most common among them is the graphite, which is carbon, and of course platinum. They are often used as electrode during electrolysis. The electrolyte is another concept I would like to define. It's a chemical substance that conducts electricity either in molten state, fused state, or in solution, and they are decomposed. There are two types of electrolyte, the strong and the weak electrolyte, depending on their degree of dissociation. Strong electrolyte dissociate completely, while weak electrolyte dissociate partially in solution. The conductor is a solid substance that allows the passage of electric current. Now, there are basic difference between electrolyte and conductor. While the conductor conducts electricity in solid state, the electrolyte conducts electricity in molten state, fused state, or in solution. The conductor conducts electricity via the use of mobile electrons, while the electrolyte conducts electricity using mobile ions. And of course, finally, the conductor does not decompose and the electrolyte decomposes. Is mechanism of electrolysis. On applying electric potential through an electrolytic cell, the electrolyte in the molten state or solution dissociates, giving rise to cations that are positively charged, migrating towards the cathode, and anions that are negatively charged, migrating towards the anode. For example, the electrolysis of dilute sodium chloride. Sodium chloride in solid state cannot conduct electricity because there are no mobile ions. Of course, we must add water, and making it into solution will cause the dissociation of ions, having your sodium ion, chloride ion, hydrogen ion, of course, hydroxyl ion. Now, these four ions will have two of them that are positive going to the cathode and two of them that are negative going to the anode. And we refer to it as at the cathode reaction or cathodic reaction. At the cathode, sodium will accept one electron and become sodium solid that is deposited, while hydrogen will also accept one electron and liberated. But you know that hydrogen is not a monoatomic gas. It cannot be stable at that state. So to balance the equation, we add 2 ions of hydrogen plus 2 moles of electron to have a stable hydrogen molecule that is liberated at the cathode. Then at the anode or anodic reaction, chloride ions will lose 1 electron, as the case may be, and it will form a chlorine atom. And chlorine is also a diatomic molecule. So if you balance in that regard, you will have a molecule of chlorine liberated also at the anode. Then the OH, or hydroxyl ion, will will liberate oxygen at the anode plus 2 moles of water and 4 moles of electrons. And that's how it goes at the cathode. But you agree with me that these 2 ions, either positive or negative, cannot go to the cathode or anode at the same time. So there is need for one to go per time. And that is why there is need for preferential discharge of ion. Preferential discharge of ion is the selective discharge of ions. There are factors that affect the preferential discharge of ions. And these factors include the relative position of ions on the electrochemical series, the concentration of ions in solution, and the nature or types of electrode. Let's look into this briefly. Relative position of ions on the electrochemical series. Now, electrochemical series is the arrangement of ions in order of their decreasing electropositivity. By this, any ion that is beneath the order is preferably discharged. Now, if you look at the arrangement of the electrochemical series, as we are going to see shortly, you find out that the cations are arranged from potassium to silver or gold. And we also have from tetrasulfate 6 ion to hydroxyl ion, meaning that silver is the least and hydroxyl ion at the anion is the least. Such that in an electrolytic cell, where you have sodium chloride dilute, you will find out that when sodium and hydrogen are in the same competition, hydrogen will be preferably discharged because hydrogen is beneath sodium on the activity series. Likewise, oxygen in hydroxyl ion will be preferably discharged because hydroxyl ion is beneath chlorine or chloride on the electrochemical street. On the next slide, you will see this reaction being displayed as I have explained earlier on, and we'll move further as we move regard to discharge of ions. Students, I'm sure you're coping with this lesson. Sit tight and enjoy more of it as we proceed. Concentration of ions. Any ion that is more concentrated than the other is preferably discharged. But this is more pronounced with the anions because they are of relatively close strength, unlike the cations that have wide range of strength. So you find out that in the electrolysis of concentrated sodium chloride, chlorine is preferably discharged to oxygen regardless of the position on the electrochemical series. Why? Because chloride ions are more concentrated in that solution. Nature or type of electrode. There is inactive electrode I mentioned earlier on. They are called inert electrode. These are electrodes that are not attacked or do not participate during electrolysis. And of course, we have active electrode. Some ions have more affinity for certain or particular electrodes. An example is the case of mercury and sodium, and this can form a complex called sodium amalgam. Having set the factors that affect the preferential discharge of ions, we'll be going into the concept of Faraday's law of electrolysis. We are all aware that Faraday is the father of electricity. He came out with two laws that help us to apply electrolysis in calculation. The first law, which is known as the first Faraday's law of electrolysis, states that the mass of a substance or element deposited or liberated during electrolysis is directly proportional to the quantity of electricity that is passed through it, meaning that M, which is mass, is directly proportional to Q. You find out that Q is equals to IT, where I is current in ampere and T is time in seconds. When we move to the next slide, you will see that we have also introducing the proportionality constant, where we have M is equals to KIT. When you make K the subject of the formula, you have K equals to M over IT. But the reciprocal of K represents the charge to mass ratio, such that 1 over K is equals to IT over M. Remember, our M is our mass, our I is our current, our T is our time in seconds. My viewers, the second law of electrolysis I would like to make quickly because we'll use the examples to illustrate how these laws can be applied. It states that when the same quantity of electricity is passed through two different electrolytes in a series, the amount in mole of each of the elements liberated or deposited is inversely proportional to the charge on the ion. Mathematically, you can see N representing number of moles, proportionality sign, 1 all over C, which is the charge. If you do the mathematical representation, you arrive at the conclusion that says N1, C1 is equals to N2, C2 is equal to N3, C3 is equals to N4, C4 is equals to NN, Cn, as N represents the number that proceeds. My students, it's good that we look at how you can apply this law to solve simple calculation problems on electrolysis. I'll take you through my two questions quickly, and I will show you which law to apply per questions as we move to the next slide. And on electrolysis of aluminium chloride, a current of 1.7 amperes was passed through for 2 hours, 5 minutes. Calculate the number of moles deposited, where aluminium has atomic mass of 27, and the Faraday constant is 96500 coulombs. B. Assuming 0.058 mole of aluminium was deposited on passing a current of 5.43 moles, find the time taken to the nearest minutes. Number 2. A quantity of electricity was passed through two cells in series containing copper 2+ and silver plus ions respectively. It was found that 0.64 grams of copper was deposited at one cell. How much of silver in grams was deposited in the other cell? Copper being 64 grams and silver 108 grams. Faraday's constant remains 96500 coulombs. My viewers at home, having come this far, it's now time to apply the first and second law of electrolysis to solve problems. As it has been mentioned earlier, these questions have solutions. I said there are several methods you can adopt to solve this problem, but I choose the proportionality method, and subsequently we might have to apply the formula. Now, looking at the board, the equation shows that 3 electrons will be added to aluminium to deposit 1 mole of aluminium. The data that I are given in the question include the current, which is 1.75 ampere, and our time, which is 2 hours, 5 minutes. We have learned from primary school that 60 seconds make 1 minute, 60 minutes make 1 hour. With that factor, we can convert our 2 hours by 2 times 60 times 60, plus in our 5 minutes times 60. Or not, alternatively, you can convert the 2 hours into 120 seconds and add your 5 minutes, making it 125 minutes. Then you multiply by the factor of 60, and our final answer will be 7,500 seconds, which is the SI unit for time. Now, if you apply that formula on Q is equals to IT, where your I is your current and T is your time, you arrive at a quantity equal to 5,265 coulomb. Remember, coulomb is the unit for quantity. Now, if you use the proportionality sign, you will say 1 mole of aluminium will deposit 1 Faraday, which is 96500 coulombs, multiplied by 3, which is the charge on the ion. Then, of course, you have X mole, which is unknown, time equal to the quantity of electricity, that is 5625 coulombs. If you do the solution, you arrive at the final answer of X mole is equals to 0.19 moles, where X is the number of moles. And you go to the second question, which is question number 1B, that asks you to find the Faraday, or the time that it will take the quantity of electricity to be deposited. And if you look at the factors that we have already, you say 1 mole is equals to 3 Faraday. 0.019 mole will give you X Faradays, which is unknown. If you do your arithmetics, you will come to find out that your X will be equals to 5625 coulomb. Remember that I said Q is equal to IT. And we are looking for time in minutes. So you must make T subject of the formula. Having made T subject of the formula, you substitute 5625 all over 5.43, and you get the final answer of 1053.9 seconds. If you are asked with specific instruction to make it in minutes, you have to convert to minutes by dividing by the factor of 60. And you have it to be 17.26 minutes, approximately 17 minutes. We now go to the second question quickly, and our second question illustrates the second law of Faraday's, where you have 2 ions in the same electrolysis. Remember, the same quantity of electricity will be passed through them. So we have to find the quantity of electricity and look at the relationship that will give us the quantity of electricity, and the quantity of electricity we are going to get as X is equal to 1,930 coulombs. And we will say similarly, since silver is relating to copper in the same electrolytic cell, you will now use the same relationship, and the charge on silver is 1. So you say 1 Faraday, that's 1 times 96500 coulomb, is equals to 108, which is the relative atomic mass of, or the atomic mass of silver. And this quantity, 1,930 coulomb, will be giving you unknown mass. So when you substitute, you arrive at the final answer of X is equals to 2.16 grams of silver. Remember, X represents mass, which was unknown. My viewers, I have taken you through this method of solving this question. Remember, I said there are other alternatives that you can apply. We will see that subsequent in our subsequent lessons. But I would like to proceed to tell you how you can apply electrolysis in your day-to-day activities. The importance of electrolysis cannot be overemphasized, such that electrolysis is used in the prevention of corrosion and roasting. In general terms, we refer to it as cathodic protection. Another use of electrolysis is to increase the attractiveness of plated objects, and it's called generally electroplating. That's why you can have ornaments that are not gold but can be coated with gold or silver or copper, as the case might be. Then we have, it is used for the manufacturing of some compounds. These compounds are like hydrogen, sodium hydroxide, and so on and so forth. Electrolysis can be also used for extraction of metals that are very, very electropositive. These metals like potassium, sodium, aluminium, calcium, just to mention but a few. Finally, purification of metal. Certain metals are gotten in impure state or combined state. To purify them, you can adopt the electrolysis. Example is copper tetraoxosulfate 6, where copper is obtained in pure state. It's time to go. I wish I could stay longer, but join me some other time as we're making exciting presentation in chemistry. Good day.
Good day, viewers. Once again, you are welcome to this e-learning program. My name is Williams Ishaku. I am here to make a brief review of what my colleague, Mr. Philip, has presented about the topic electrolysis. I believe you have learned. However, he talked about electrolysis. He started by giving you the definition of electrolysis as the chemical decomposition of compound through the passage of electric current. And he said whenever we're talking about electrolysis, there are key terms that we need to understand. One of them is electrolytes and electrolytic cell. What is an electrolyte? He started by defining an electrolyte as any substance that can allow electric current to pass through it with decomposition. One may wonder whether electrolyte is the same thing as conductor. We know that the two are different. A conductor allows electricity to pass through it without decomposition, while the other one allows electric current to pass through it with decomposition. He said again, we also have the electrode. The electrode is the pole in which this electric current enters the cathode, the electrolyte, or leave the anode, the electrolyte. It is divided into two. We have the cathode and the anode. With this, I believe you have learned. The next time we are going to make another presentation that will help you to know more about this electrolysis. Thank you. Have a good day.
Good day, my students and viewers at home. As my able colleagues, the two of them, Mr. Philip and Mr. Ishaku Williams, have introduced and solved everything about electrolysis for you, I would like to tell you what you might expect, possibly in your WAEC and NECO. So I will do that by giving you some questions to try at home, as well as I will give you our number so that if you have any further problems, you send it to us so that we help you so that your exams will be good and fine. So the first thing here is assignment. The first question on the assignment is you are expected to differentiate between the following. 1, electrolyte and conductor. 2, electrolytic cell and electrochemical cell. 3, electrochemical series and activity series. Here it is very important to take note of this, that whenever you are solving questions that involve differences between two or more entities, you are expected to draw a table. Make your table clearly. On one side of the table, write it, electrolyte. On the second side, conductors. Give your corresponding differences between the two. It is very important. That is what is expected of you. Then question 2, write the cathodic and anodic reaction of the electrolysis of the following. 1, concentrated sodium chloride. 2, water by adding few drops of tetraozosulfate 6 acid, that is acidic water. Also here, it is important to know that even a concentrated solution has water in it, but the difference is that the concentration of the sodium and chlorine ions are more than that of the ion. So we are expected to use the second condition for preferential discharge of ions, where you have differences in concentration of the ions. Then question 3 and 4 involves calculation. Here, take your pen and paper and write it. Question 3, a solution of silver trioxonitrate 5, that is AgNO3, was allowed to undergo electrolysis under a current of 2.75 amperes flowing for a period of 56 minutes. You are expected to calculate the mass of silver deposited. 1 mole of silver is equals to 108 grams, and then a Faraday constant is equals to 96,500 coulombs. I'll take the question again in case you didn't get it. A solution of silver trioxonitrate 5, AgNO3, was allowed to undergo electrolysis under a current of 2.75 amperes, flowing for a period of 56 minutes. Calculate the mass of silver deposited. 1 mole of silver is equals to 108 grams, and the Faraday constant is 96,500 coulombs. So you are given the current to be 2.75 amperes. You are given the time to be 56 minutes, in which you are supposed to convert that minute into seconds. And also you are expected to find the mass. So I want to give you a hint. You are expected to use the first law of electrolysis for this calculation. Then finally, what volume of oxygen gas will be liberated at the anode at the same time as 13.7 grams of copper at the cathode on the electrolysis of copper 2 tetraozosulfate 6 using platinum electrodes? I will take it again. What volume of oxygen gas will be liberated at the anode at the same time as 13.7 grams of copper at the cathode on the electrolysis of copper 2 tetraozosulfate 6 using platinum electrode? Here, you should know that the electrode is inert. It will not take part in the reaction. The only thing you are expected to is you should know the mass of copper that is liberated. Then you use the second law of electrolysis, the charges on copper and then the charges of the oxygen to calculate the equivalent number of moles of oxygen that will be liberated. Putting into your mind that 1 mole of any gas at STP will give you 22.4 dm³. You use the proportion method there to calculate. So, thank you very much, my viewers. But before I go, in case you have any problem, you solve this question, you want to verify whether you are right or wrong, or you have further questions that you want to communicate to either I, Mr. Williams Ishaku, or Mr. Philip, you can contact us using these our numbers.